Hello everyone, welcome to the next session on ABAP on HANA. In the last class, we have talked about how to optimize your ABAP program using aggregate function, and also we have started introduction of information modeling in SAP HANA. In today's class, we will have a deep dive inside some of the information models in SAP HANA and try to create some information model at the database layer to achieve the results or performance results what we desire to achieve by pushing down calculations right into the database. With the introduction of SAP HANA information model, we realize that there are four types of information models: attribute view, analytical view, calculation view, and decision table. The first three type of information model are majorly used for real-time scenarios, and the decision table used for planning scenarios. The difference majorly between these three models is the way they are executed in SAP HANA Index Server. Attribute view is executed by a join engine. Analytical view is processed by OLAP engine, which is built for performing aggregation. So if I just also note down, built for performing aggregations on fly. Calculation view is executed by calculation engine. The calculation view is further classified in graphical and SQL script type of calculation views. Moving on, we have discussed about data in a company. How does it look like? We also talked about dimension and the measure. So dimension in a company would be representing a master data, which will be typically surrounded by a measure to give a different perspective. So we took an example of sales data with customer and sales representatives. So when we combine the sales data with different perspectives of or with different dimensions, we get altogether different perspectives. For example, if I combine the customer data with the measure of sales data, which is nothing but a fact table, we will get to know which customer is purchasing more, which is the priority customer. At the same time, if I combine with the perspective of sales representative, I will get to know which is the most important sales representative in my company. The same time, we can also look at the product wise, that which product is selling more into the market by looking and joining my sales data with the product data. Correct? So like all these things, we observe that we have done it. So now we can also see that likewise we have two different, or likewise what we see here is a fact table surrounded by multiple dimensions. This is together known as a star schema. Now similar to one star schema, it is also possible to have other star schemas. And when we want to combine such a complex set of star schemas together, it becomes a calculation view, which is the uh, third type of modeling techniques. So in today's class, we will go ahead and discuss about creating these artifacts, which is nothing but your attribute view, analytical view, as well as the calculation view in the system. We will getting into deep into the nitties and gritties of these different variety of view types and see which case, or try to understand typically how can we achieve the desired results by using these things. So in today's class, what I've done for today's class is I have actually make use of SAP HANA Studio to be able to perform the actions related to today's class. So Eclipse development tools also provides you an option with a modeling perspective. With the help of this modeling perspective, you will be able to build the data models. But SAP HANA Studio is a dedicated to also achieve this. So with SAP HANA Studio, which is also nothing but a client based on Eclipse, would also provide you an opportunity to build these data models quite easily. Okay. So that is why I had installed SAP HANA Studio in my system. You can get the SAP HANA Studio from internet, from our same cal server, or you can also download from service marketplace. In addition to that, to showcase another type of scenario, what I have also done is I have downloaded from service marketplace something called a HANA MDX provider for MS Excel, so that I can show you dumping some data directly from our HANA system into an Excel sheet for some kind of a special scenario, which I will talk about. So with that, let's proceed on and try to look at our business case first, what we are trying to achieve. So as I have explained you the sales data, we will be combining it with the product data. So what I will be doing is I will be writing first of all a dimension which needs to be created. A dimension needs to be created, and this dimension will include all my product data. So I'm just creating one dimension, which is product dimension. Okay, that's the dimension I'm creating. Now my product data has information about product, which is distributed in my EPM model in different tables. So the table which I'll be using is SNWD underscore PD, which is the product information. Then I have the same table containing who is the supplier of this product. So there will be another table called SNWD underscore BPA, which holds all my business partner my company is doing business with, whether it be a supplier or a customer. So that is my next table, which is the business partner table, which has the information about suppliers who are providing me the data. So I want to create a comprehensive model which gives me information about both my business partner as well as the products. So let us go and try to create now an attribute view in the system for that. And to derive the data from multiple tables together, we got to use joins. We will also talk about different variety of joins available in SAP HANA system later in today's unit. So that this is so that you will be able to understand in which case to use which type of join. It's also very important interview question when you go for SAP HANA interviews. So to create an attribute view, basically it's a dimension which you're creating using master data. So I'm creating an attribute view. What is that you need to mention? So in step number 1, you need to mention the name and description of attribute view. Step number 1. In step number 2, you got to mention the table names and the joins which are required to perform the create this attribute view. Additionally, you can also mention hierarchies in your attribute view. You can also mention transformation, restricted and calculated columns. We will talk about them in detail also later point of time. Then after that, you can just save and activate your view, and then finally you can do a data preview in HANA Studio. Why am I using HANA Studio? Because it also gives you a nice graphical representation of data which your ABAP and on Eclipse tool will not give you. You can still of course do same activity in ABAP on Eclipse, but it won't give you graphical representation. Since I want to demonstrate graphical representation, I would be interested to showcase this example in HANA Studio. Now when you look at the attribute view design, it basically consists of something called a data foundation. Data foundation includes your tables with selection, join, and conditions based on which you would like to retrieve the data from the database tables. And finally, it includes something called a semantic. A semantic provide more information about your data model. Example, if you want to design a hierarchy, so you can do it with the semantic. You also got to classify your key fields, which are all going to be my key fields in my data model. So you're designing a dimension for product. So product ID is essentially you would like to make it as a key field, right? So that is what will be defined using semantic of your data model. Okay, so let us go ahead and build it. But before that, let's also quickly understand. So yesterday we were talking about schema in HANA. So if I connect to my HANA system, you can see in the catalog folder, I see all my schemas. So schema is the compartment of database, the way you organize your data. The major advantage is to segregate the data and apply the constraints, data constraints centrally managing all your database objects. That's an advantage of using schema. Then Now we will quickly look at another section called catalog, or sorry, content. So content is nothing but it's a collection of packages with your development objects. Okay. So what is content in SAP HANA? Content is a collection of development packages where we add different development objects, including information models. So when you want to create an information model, so this is information model in this case is a HANA specific data type. Okay, so attribute view, calculation view, decision table, all this is only known by HANA database. Your Oracle database or any other database will not know these things. Okay, for a normal database, if you look at RDBMS or a normal database only knows a concept of a view actually, which is typically also known as a column view. Okay, a typical database system only knows concept called column view or a view. It doesn't know what is, whether it's a information model of type attribute view, calculation view. It doesn't know that. It only knows the concept of a column view. That's what exactly database knows. So it's a very HANA specific data type. What you are having here, which are these different type of views, are actually HANA specific definitions of information model. So where do you create them? You can't directly do that with the database. Of course you can do it, but you got to write complex statement, like I was discussing why there was a need of an information model, because writing or reading the data using a SQL query is challenging all the time, and there are also a lot of things which you would not be able to do it with the simple SQL queries. That's why you have a concept of information model. But ultimately when you activate a model, it creates a view at the database level, because this is very a broad concept in terms of database, a view. So you will create an information model in the content folder. Basically you will be creating a package, because content is a collection of packages, and for your company or your team there will be a dedicated package. Now what is the advantage of using a package? So package is actually provides a namespace for your development object. Why? Because what happens is when we activate information model, it creates a view in the database. So for actual database, this is actually just a view. Okay. Now what happens is, let's say I am working. So where we were. Okay. When we activate the information model, it creates actually a database view. Yeah. Now imagine you're working in a company and you have two different teams. So there is a team called sales team for which you are developing a software, and there is another team called, let's say, purchase team, and both are doing order item analysis, open item analysis. So purchase team would like to know what are all the open item or open items which I supposed to receive from the vendor. And at the same time, the sales team also would like to know how many open invoices are there for which I need to collect the payment. Yeah. So they will purchase team calculate dues which you need to pay to the vendors. Sales team calculate the pendings from the customer side. So they will end up more or less to similar artifacts with the name called pendings, let's say. Now what happens, you have one database system. Now can anybody tell me, in SAP system can you have two different tables with same name? Can you have two different Mara tables with same name? Of course not. Similarly here, what happens is you cannot have two different views with same name. Okay. But that is something which HANA allows you to have same name of views, because you have a package, and the object which is created will, its name will be prefixed with package. I repeat again, in HANA it's possible to have two different views with the same name, provided that they belong to different package. That's why we say it provides a namespace. You can prefix, or basically HANA prefixes a package name before the view name when it is activating the view. So both the teams can have their same name of views but dedicatedly in their respective packages. So what's the naming convention which HANA follows? It follows package name and then double colon and the view name. This will be the name of the view which will be created in underlying database finally, and this will also get stored inside a schema. Okay, remember guys, this gets stored in a schema. Okay, and the name of the view will be actually the view which is persisting in DB will be the package name double colon the view name. We will see this in the system. Once we create any type of view, we will see this in the system would be doing that. Okay, absolutely. It also gives you a possibility to transport all logically related development objects together. Like in SAP, we create a package and under which we put all our programs, we put our function modules, function groups, everything we put inside, right? Similarly, here also does the same thing. Using the package, it provides you an opportunity to group your development artifacts together. It provides a namespace, plus also allows you to transport it with the delivery unit. So in our SAP HANA, there is a concept called delivery unit to transport your data or your objects via HANA database to the production system. So for a given package, there will be a delivery unit which will be selected, just like a transport, and then that delivery unit once transported, it ships your data to the production system, ships your development objects to the production system. So these are all the major reasons why we have packages, and ultimately the view name will be the package name double colon the view name in the schema to which the package belongs. So package also ultimately belongs to a schema, but just to start your development you got to use this content folder, and if I expand it you can see these are all the packages right now in my system. And now what I'm going to do is create a new package. So let's right click, new package. In my next course of SAP HANA XS development, I will show you this package also plays a quite important role, because you have a concept called repository in SAP HANA. When you create a folder in SAP HANA repository, it automatically creates a package on the server side in the content directory. Okay, that is something just for your information. When you look at my next course, SAP HANA Access and Access Advance, you will understand that what does it mean for the development in SAP HANA. Okay, now coming here, I'll just give a name for this package and I just name it as, let's say, uh, I can say my analysis, or I can say sales team. So I will write all my relevant objects in this sales package. Okay, and then I can just choose the delivery unit. Right now there's no delivery unit created, which means the package remains as it is within my server. I don't want to transport it, so I just keep it empty. And you can see now here the person responsible is my user. Yeah, now I click on OK. So it will create a new package for me over here. You can see the package has been created called sales. This package is right now empty, there's nothing inside this. Now we will just go ahead and create an attribute view. So right click, new attribute view. Here you can choose, click on this, it would pop you up a window. So that's your first step, providing the name of the attribute view. So it's 80 underscore, I want to create a dimension for product. So that's a product dimension, and I can just give a label for this product dimension. And then it's an attribute view, and now you look at the subtype of the attribute view, what type of view it is. It's a standard, time, or derived. So there are these three different variety of attribute views which we have. We will not look at each one of them, but just I want to quickly explain you what is the each type of attribute view you have it here. So standard attribute view is what you use most of the time. This is a general attribute view type to create dimension. The second attribute view type is a time dimension or time attribute view. What is a time attribute view? So you remember a used case which I was explaining you yesterday, that you can have one dimension as a time to look at your data. For example, I want to know how many laptops were sold in the month of in the last quarter of 2017, or how many cars were sold during Diwali season. Okay, how many uh, pen drives have been sold during Christmas season. So you got to look at now the data with the perspective of time and the product. Yeah, so that's what you got to do it to analyze such kind of results. So that is why we have a time dimension over here, which will help you to achieve this. And when you creating a time dimension view, you will be using standard time tables. Maybe I will show you creating a time dimension today also in today's class. So that is where we use the uh, time as the subtype for the attribute view. So this is used to create time dimension. Then comes is derived. So you all know the concept of inheritance. Derived means inheritance simply. So you can create an attribute view same as another attribute view, and that becomes a derived attribute view. So this is the concept of inheritance. So inheriting from another attribute view. Then question comes, Anubhav, what does it mean then? Why are we duplicating a view? Yeah, so that is pretty much required. Why? Let's look at some data of payroll. So let's say you have payroll data, and here you have information about in which month how much salary was given for each employee ID. Okay, so you have month, employee ID, and what was the salary I paid to employee in this month, to every employee. This is your payroll data. Now you have a table called employee table, and this table includes information about all the employees. Now can anybody tell me, will I have separate table for normal employee and managers? Anybody? Do you think we will have separate data tables, one for managers and one for other employees, and one for CEO, one for co-CEO, one for vice presidents? Of course not. You will have one table where you have all the employees with their designation in the company as a field. Yeah, so that is what you will have. But my requirement here for modeling is, I want to know in my company in a certain time period how much total salary I have given to employee and how much total salary I have given to managers. So I have got two different dimension. One dimension is a normal employee who is not a manager. One dimension is a manager who is actually an employee also. Yeah. So I've got two dimension in this case to analyze my data from different perspective of payroll. Isn't it? Very valid requirement. So in that case, would you think I will copy all the data from my employee table to another table and then create something on top? I won't do that. I would just create a view called employee, and then I will create a derived view with the name called manager, just the name change, and apply an additional filter here on designation manager. That's it. That's what I will do. I will create a derived view from the existing view what I have created for employees. And then I can find easily, I can analyze my data. So that's where the derived view comes into picture. It is just an inheritance from an existing attribute view, and on top apply some additional filtering. Okay, these are all the nitty gritties of SAP HANA development. As an ABAPer, you may not need to build all these things yourself, but you should have at least some idea. As I was mentioning yesterday, you should know these concepts at least, so that when you face these things, when you look at these things, at some time you get across these things, you know what they are talking about. Okay, so that's about these three different types of attribute views. We will see creating a time attribute view also, and also maybe a derived one. So I use right now standard, click on finish. A new attribute view will be created in my sales package, and then I will be able to open that up. So yet again, if you just to remind you, we will have two things: data foundation, which includes all the tables with their selection, joins and conditions, and then the semantic for my attribute view, where I can mark the columns as a key column. I can additionally mark hierarchies if I need. So all that information will be available. So you can see it has opened a nice graphical editor. Same thing will work also on ABAP on Eclipse, which we were using by far. But I love kind of the way using HANA Studio because I'm used to it. I have done some HANA development in past, so I'm kind of used to this UI. And also it gives me better representation of data in terms of graphics, which I will show you in a minute. So let's quickly double click on data foundation, and now you can start drawing your tables and their respective joins over here. So now we're going to bring the tables, so you can click on this nice plus button, or you can also open up your schema and drag and drop the tables if you need. So I can just come here, say EPM model. Can I find all the tables here? Right? No. Maybe I just go to right click on the tables in the schema. So I have my SAP A4H schema from my ABAP system, and I'll just do a right click on this tables over here, and then just click on filter SNWD star to get all my tables which are starting with SNWD star. Yeah, that's all. I just do it, expand it so I can see my database tables having SNWD into it. So I will be using my product table and my business partner table to define a join between these two. So let's just check it out. It's taking a little bit of time to pull the information from my DB. We can also click on plus button over here and then search for the table. So SNWD underscore PD is the product table. So let me just search. You can see here we've got the table from the schema. So I click on the table, click on OK. The table will be dropped over here. You can see it has come. So you don't have to write complex queries to define the conditions on what basis you would like to pull the data. And now you can see here we have a supplier GUID, which will take you to who is the supplier of this. But the data for the supplier is there in the business partner table. So SNWD underscore BPA table. You already know about the data model. And then I just double click and pull the information from the BPA table. And then there you go, it comes. And then for each business partner, you have address data also for the business partners. So you can pull the address data also to join it with the business partner table. So all about master tables, guys. Remember, when you're creating attribute view, the golden rule is add only master tables, the data which seldomly changes in the system. Okay, don't add the tables which are relevant for transaction. You can add it. Remember, in attribute view there is no restriction that you cannot add a fact table, but ideally you should not, because performance will take a hit, because attribute view is processed in the join engine in SAP HANA. It's not processed by OLAP engine, which is equipped to perform aggregations well. This should be your answer. In interview they may ask you why you shouldn't add uh, or can you add a fact table in attribute view. You can say yes, we can. Point two, then you say why you typically don't do that. The answer should be that first of all, according to the guidelines, a fact table should always be part of analytical views. Second reason, technical reason, is that analytical view processing is done by OLAP engine in SAP HANA, which is built for performing aggregations always. And when you use a fact table, you always try to perform aggregations, and aggregations are always processed faster in OLAP engine as compared to join engine. And that's the reason you should go ahead and put the fact tables always in always in analytical views. Okay, now I also add the contact table, business partner contact information. So you can see this has also been added. Now I just want to also add quickly the product category table information. So product category table also I'm adding. Hope I'm not making it too complex for you to understand. Just trying to showcase that all the different tables I'm adding. So I think this should be the product categories. Just double click on this and all the tables from my SAP A4H schema I have added. There is no fact table in this example. I am creating an attribute view. Okay, there is no fact table. Ideally, you should not add any fact table inside attribute view. I double click, it will make it little bigger. Okay, I've got my tables. Let me just quickly arrange them little nice way so that I can now go ahead and apply a join in these tables. Great. So these are all my tables. Let's find out the join relation. So business partner node key should match with the supplier GUID over here. So that's a join which I made. I just drag and drop from here to here. That creates a join. And then I also double click here nicely to this join and just mention what type of relationship it is. So typically the join. So here you can have a supplier GUID in a product. There is only one supplier per product. So it's a one-to-one relationship. So you can see join type as referential. I will come back to this point. What are all these different types of joins in SAP HANA? So I'll choose cardinality is one-to-one. You can see also temporal properties. I will explain you what is temporal properties all about. Click on validate join. On referential, this is all fine. There's no problem as such. Click on OK. This join is done. Second is between the business partner name with the contact details. So now I think it's here address GUID which connects these two. So node key with, sorry, I think it's parent key with the address GUID. Double click. One-to-one yet again. So there is for one business partner. Okay, sorry. For one business partner, there may be multiple addresses from where the business partner is operating. So it's a one-to-n. Okay. So one-to-n join. Okay, I think I just have to drag from the left side and drop it on the right side, parent key, and then just make it one-to-n. Perfect. And now you can see here the category information. So I just joined category with the category. I'm not sure if I am joining it the correct table. I've never used category table, but just try to do this. So we are done with the join and the cardinality of each of the joins. So you can see there's a product data. For one product, there is a supplier, which is a business partner. And for this supplier, there are multiple addresses which are available. This is all master data. And then you have a category and there is another category. Now, once you added all these columns, you got to also tell the system what should be exposed. You remember the guideline that you don't expose all the columns from database, isn't it? You remember that to minimize the data transfer from your database layer to the application layer, you got to also minimize the data transfer by selecting less columns. You see this guideline. So would you expose all the data from all the tables, all the columns? Would that be really required? Of course not. So you would probably want to do analysis with product ID or product name or business partner who is supplying you some certain products. You would not need all the columns. To abiding to this guideline, you should never ever expose all the columns from the view, and may not be necessary. You see, these are just technical keys which are used to define the relation, but you would rather not likely to expose this data outside, isn't it? So that's why I would now can select the product data which I want to expose. So I say product ID, add to output, product type, product category, main category of the product, and then maybe just want the currency code of the product, price of the product, and then I can just say which is the company who is supplying this product and what's the title, the person who is there in this company with whom I'm in touch to get this product information. That's all the information I need. And now I can just quickly save this first. So that's all my columns. You can see all the columns have been listed down over here. Now I click on semantics and you can see these are all the columns which I have selected. So for certain columns, you can also mark as hidden, which will not be exposed to anybody. Nobody can use those columns in the join if you make it hidden. Now I can also define a key, which is my product ID in this case. I also probably want the GUID of the product. So let me take the GUID of the product in the output and make that as my key rather than product ID, because this is actually the technical key for my product dimension. So I come here, I got to save this first, and my node key is here. You can see I just mark it as a key, click on save. Now let's come to the view properties. So you can see here that what type of privileges will be applied to this view. So there is a concept of analytical privileges in HANA. We will come to it later. So this is all about control, DCL, data control language. What kind of privileges are required? So I say classical privileges, which means if I have select rights on the schema in which all the tables are present, I will also have select rights on this attribute view. Then you can see this is the view name which system is going to create in the actual database. You remember I was telling that when you create an information model, it actually creates the real column view in the database, because for a RDBMS system or DB system, it's nothing but more than a column view. So that's the name of the view. And can anybody tell me by default in which schema your view will be created when you activate it? Anybody? Which is the schema in which system is going to create your view, your information model by default? It's given here clearly. You see the tables you used is from SAP A4H, but the schema in which it is creating the view is sysbig schema, because your package also by default belongs to sysbig schema. Okay, this is a system schema in which system is going to create your view. Okay, can you change this? Of course yes, if you have your package created in a different schema, but right now we don't have rights with this user to create it in a different schema, but you can ideally do that. It is possible. So this is the schema in which my view will be created, and you can also mark it deprecated if this view is of no use. So it sometimes in production it happens that a view becomes obsolete, so you can just make it deprecated. Now there's also another advanced settings like cache. So just to bring you back again to the world of HANA, the hardware advancement. So where the calculations are typically taking place is the CPU. So CPU includes something called registers. These are also known as caches. So CPU has caches and registers where the actual calculation takes place. Then the data is stored in the RAM, which is nothing but your in memory. And then you have your final hard disk, which is holding the backup information. Yeah. So there is also now the new bottleneck that if the data needs to be processed, it has to be pulled from the RAM, brought into the CPU caches, and then the calculation is going to take place. But as you know, HANA database has amazing power of CPUs. There are a lot of different multi-core CPUs connected back to back, and these CPUs can also have these caches. So by any chance, if you have a very sensitive information which you quickly want to calculate and reduce this bottleneck between the RAM and CPU, you can also keep the data in CPU caches. Okay, you can store the data in CPU caches, and then it would not do this it will not have this bottleneck of pulling the data all the time from the RAM. But again, this would cause a havoc in the system, in a real-time system, when you mark for everything CPU caches. Then your CPU will always become the actual store rather than RAM. Okay, so it's always good practice to not make it until unless it's truly required. So that's why this setting is there. It is also saying that how much time interval, after how much time interval the data should refresh from RAM to the CPU cache. Okay, so cache invalidation period is what it's saying. So I don't do anything here. I don't want it to be kept in the CPU. You can see, please set them cautiously. We don't need that. It's not that performance problem right now for me, because I can also further on observe what is the performance I want to gain, and accordingly I can change this setting. Then comes the hierarchy. I will explain you the purpose of hierarchy later point of time. This is mainly used for showcasing the data at different levels, level based information. I will show you a use case for that in today's class. So with that, we are done with this, and we will just quickly save it and just come back and just do a quick check here. So there's this nice button to do a check on the data layer. You will see in the job log at the bottom how is your check is doing. So you can see it's running the check on your data foundation, or basically on your data layer. So once it complies to all the rules of the game, your joins, your conditions, everything what you had put, it simply says completed. So you can see completed with warning, which means still we can go ahead and process this view. Let's activate. So there's this next nice button called save and activate. I click on that. You would again see the log at the bottom telling you whether it's activating this or not. So just say this is a production system, manipulate data on this system with caution. Do you want to continue? I say fine, no problem, please continue, and activate my data model in the system. So on activation, system would actually create the real column view in HANA DB. Okay, the real column view will be created in your HANA database on activation of this. So you can see now it has started the activation process for my data model, and this would end up creating a view, which I also showed you the view in the semantics. So if you can go to semantics, view properties, you will see a view over here. In sysbig schema, there is a there is a folder which gets created with the name of package, under which your view will be created. So you will see it's completed successfully. Perfect. Let's go and check this. I copy this name, sales 80 product dim. I go to my schema, sysbig schema, which is the default schema in HANA DB. I can go to column views and I can find that view over here with prefix with my package name. So you can see here itself, sales slash attribute product dim. Yeah, this has been created. Now, you know the beauty of this, you can fire a select query directly on this attribute view. So you can go to SQL console and fire a select query directly on it. So you have saved a lot of time writing SQL, performing writing select from this table, join this table on this, and then again further join this table on this. All that you saved a lot of time by using this graphical modeling technique. This is called data modeling. Even a business consultant having idea about data with little bit of technical knowledge can achieve this. That's the whole game. That's the whole idea of having model. So select star from the database view, drag and drop, and just execute. You're going to see all your data here into the console. If our joins evaluate correctly, it will come. You can see there's some problem in our join. That's why the data is not coming. Even you can come here and click on this data preview button. You would see your data. But since the data is not coming, there is I suspect there is a problem with one of our join. So I can come to raw data and you see there's no data, which means I suspect there is one of the join which is kind of causing a failure. Let's evaluate them. So I would rather like to do that by removing some tables. So I suspect that it could be because of this node key with BP and supplier GUID. It could be because of this, or it could be because of this category table. So let me first remove this category table right now. I remove it, activate again, and just check if it works. Let me just give a shot. We'll see. It's again running the activation. So it could be because of any reason. We got to just carefully check it. Completed data preview. Just execute. Okay, there's a problem. Did I remove the column which I've selected? Yeah, that column got removed already. So let me just do a data preview. Raw data. No, still it's not coming, guys. There's some problem in our join, which means, so let's quickly check. So here is this node key, which is business partner ID mapping with supplier GUID. And then we have this Parent key. Let me just remove this address table also quickly just to see, and later on we will include it again. So at least not required. When you click on activate, it automatically save it first and then it does the activation. So no required for saving separately. So ideally this is the right way of developing it. So you first put your first brick, which is one table with two table, and then keep on adding more table and keep testing it so that it at any point of time your join goes bad, then you will get to know. Okay, let's see. And voila, you can see finally my raw data is coming up over here for my product. You can see the data is coming. So in this, now I have only two tables involved. One is my product ID table, product table, and the company name who is supplying this product. You can see this is the company who is supplying the product, which means my business partner address table is causing some problem for me while joining. Yeah, so let's bring in that again and see what problem it was causing. I think there's some joining issue with that table. Maybe we will do a select query and see what is possibly the reason of join between these two tables. So I'll just come back to my SQL console and simply pull that table information from my SAP A4H schema. Go to clear my filters. Let's apply just with SNWD. If it shows me that the tables for my business, my EPM schema, I just also mention SAP. I just do a select star from my business partner table. Okay, it's coming now, all the tables. I just pull the table from business partner here. And then I just say as business partner, join. And the second table is business partner contact as contact on business partner table dot. Let me just say, is there any address GUID which I can use? Maybe I just right click on the business partner table and say open definition to see what are all the columns I have in my table, business partner table. So basically there will be an address GUID column which I will be using. So address GUID. And then there's a contact table in which there will be some key which I will be using. Right click, open definition for contact table to find out which key could be useful. So basically I'm performing this manual query to find out the right join condition between these two tables. So let me do it with the node key. So earlier in the data model I used the parent key, but now I'm using node key to see if it works. Execute. Data doesn't come. Let me do it with parent key. Execute. Data doesn't come. Now my suspicion is, would my business partner contact table has at least some record? Let's check it. Right click on business partner contact and open content. See if at least it has some data into it. And if yes, then which is the yes, it has some data, you can see. Then which is the column which is going to use or participate into the join? That's my concern. So let's also look at the data in BPA table. Open the content. We will find the right selection criteria, basically the join criteria between these two tables. So let's see that. So here is my business partner table and I have my address GUID here. This is my address GUID. I copy this record and open in a notepad, paste it over here, and it was 1241 something E2. Here is the GUID. I copy this GUID. Was it the only GUID? No, there is further GUID to it. I think this is the right GUID. 2015. There are multiple GUIDs actually. Which one is the right one? Need to check which is the right GUID. So there is this column web address. After that, there is a GUID. So after web address, okay, there are too many GUIDs here. 6BE at the end. All are 6BE. 1241 A4C 6BE. A4C 6BE. This is not the one. Yes, this is the one. This is the right GUID. Yeah, after sap.com. Correct. So I copy this GUID from here and just check in the business partner address table where is it matching. So I come here, do a search. I can't do that. Let me just check. Maybe I just put it in the parent key and check it in my select query. I'll put it in the parent key and check it. So let's come to the business partner address table only, where this equals to if this GUID is there or not. F8. See, the data is not coming, which means this is not the right column. I think we are looking at a different column altogether, which is not correct. Yes, here there's another column in the contact table called address GUID. Maybe I should try joining with that. Let me try with that address GUID. So you should have a good idea about your data model, the tables which you are using to participate in the join. Then only you can, and there you go. You can see it works. So the join has to be between the address GUID of both the tables. That was the mistake we were doing. So that's how you can find out by looking at the data in the tables and then writing a manual select query between them. So let's quickly try to correct our query, which was earlier written. So both the tables, when we were joining, we should use now the address GUID. And I think it's a one-to-one relationship, not one-to-n. Okay, what's the problem now? Invalid contact dot address key. Address, it's address GUID, not key. F8. Voila, there you go. You can see now we are able to read the data from business partner and business partner address table together. So that's going to be my join condition in my data model. That's how you find it. So let's switch to the model and add the table for addresses. Business partner contact table, and now join the respective address GUID, and it's a one-to-one relationship. Fine. And then from this table, I'll just use add to output title, first name, last name of the person who is there in this company with whom I am dealing with. And from this table, I just need company name. That's fine. Let me also bring in my table which was there, which I deleted actually, which was product table. Product category table was there. So I just thought that this is the culprit. So I by mistake or intentionally deleted that. I got to bring it back and define the join once again with this table. So category of this should connect with this. And this is again one-to-one relationship. Click on OK. Activate the model. Let's quickly see now this data model if it gets activated, and finally we get the desired results. So you can see the job log is running. So I'm taking complex example considering more tables so that you can actually do these things, get used to these things. Okay, finally, let's go to the data preview. I can close the other windows. I don't like working with too many windows, and do a data preview. And you should see some raw data. And voila, there you go. All the data joined from multiple tables without writing a single select query. You're able to do it if you're a functional consultant in a company. That's what SAP HANA provides you. An amazing feature. So every product information is coming over here with who is the company who is supplying this product and who is the contact person from that company side giving this product. You can see this is non-normalized data. If you would have stored this data in this way permanently, you would have problems in database. You see this data would have been repeated. So now with the joins at runtime, the data is combined from tables, and again you are able to produce the non-normalized data. Okay, so there are some questions. Let me take them up. So if we are writing a query manually, can we see graphical view of same query? No, we cannot. If you're writing a query now on this view, actually you would see the same data also in the result set. Let me do a query and just drag and drop the view name. And then you can't see graphical data, but you would see the raw data like we were seeing over there. You can see all the raw data is coming on the view. So basically consuming now this attribute view in ABAP is easy. So somebody who have done the job for you as a HANA consultant, you can also of course now do write simple data models with my training in SAP HANA system, and now understand how to consume this in ABAP. So in upcoming chapter, I will show you how to consume attribute view, analytical view and calculation views in ABAP system. Finally, that's what you will be doing. We will see that you creating two different techniques are there, so we'll use them and consume it in ABAP system. But try to understand the major meaning of it. The meaning is the joins are calculated in HANA. Okay, the joins are calculated in HANA. That's the major important aspect you need to put your focus on. Try to push down as much as calculations, joins, aggregations into the database layer. That's when you will get performance boost. That's what ABAP on HANA is, because HANA gives you this power of performance boost, calculating your data, calculating the aggregates on fly, because HANA is more powerful than your ABAP layer now. Okay, now let's also look at this nice feature of HANA Studio, why I chose HANA Studio in today's class rather than Eclipse, because I get this nice analysis option where I can now on fly look at some graphical data. So I can just say I want to see what is the product ID on some axis, and I want to see total of how many products are there. So total of price. So what is the total of price? So you can see now which product has the maximum price. So you can see there are total two products in the system with product ID. This, I think it's price count. There are two different prices available for this product. Rest all it's same. Maybe I'll just use uh, the category on the axis, and I just say count of product ID. So for each category, how many products are there? So you can see for the category computer systems, I have 12 products in the system, and for notebooks I have maybe you can see there are 10 products. So this is something which you won't give it to your business user. You can of course save this and take an HTML file and share with your colleagues, share with functional people. But this is something which is a nice inbuilt tool of SAP HANA Studio, getting you some kind of insight of your data on your information model. You can also switch to a pie chart. A nice amazing feature is available to explain you or look at the data which you have in your database tables. Also switch to a tree map. You can see here in the tree map it shows you which product is available. How, so you can see computer system, notebooks and PDAs are the most uh, number of products in this category. You have majority of your products in these categories, and that's how you can look at your data graphically in HANA Studio. That's the beauty of HANA Studio. Yeah, you can also look at some distinct values. So I want to see what are the different variety of type codes I have. So I just click on it and you see PR category, you have majority of the products, and AD category there is only one product. Or just go by categories, you can see 10% of your total products are computer systems. 8.5% of your total products in the system are notebooks. Yeah, so very nice insight on your master data is provided thanks to the HANA Studio of doing this, and this is all calculated right into the HANA database real time. In older versions of databases, this was not possible. It used to take hours and hours to calculate such insights of data, but since HANA has all this column store, fast computation, multi-core CPUs connected together, parallel processing, all the hardware and software innovations which we discussed provides you this possibility to do this. Amazing. And that's why I recommend you to also go with HANA Studio, because this graphical tool gives you kind of good insight about your data. Okay. There's a question here. Is it possible to create a SQVI view in HANA? Are these views similar to quick view created in SQVI? I don't understand what is SQVI, Bhaskar. I never worked on SQVI. If you can elaborate what is SQVI, I would be able to explain it. Quick view in ABAP. You can write a quick view report on this SQL view which we created now, which I will show you next. Consuming HANA information model in ABAP. That's what ABAP on HANA is all about. So I will show you that, but I don't really understand the term called quick view in ABAP. I'm not sure, but this is something purely only in HANA Studio you can visit. What charts, what capabilities, what I'm showing here, distinct value analysis. Only in HANA Studio you can see that. Of course, if you want to share this information to your business users, you can take a screenshot, snap over here. You can save it as an image file. You can save it as a text file or an HTML file. These are all the possibilities. We already have it available right into the HANA Studio. Okay. Next question from Charu. So if the user want to see it, where do we deploy this attribute view? BO Launchpad? No. So basically, this is something. If you want to give it to your business user to consume, you cannot give it. This is purely into the modeling perspective within HANA Studio. What you need to do is you take this data, you will consume this data, basically write a select query on this view now in ABAP, which I will show you in upcoming chapter. Yet I have not talked about it. And then you build your OData service on top of the select query which you're writing on the view, and expose this data in entity set, and then consume it in Fiori and use a SAP Fiori application with Viz frame. There is sap.vizg library, VIZ. That library you can use to showcase the similar charts over there. Okay. So there you can build a Fiori app with SAP Viz library and consume this. Maybe we will see some example of SAP Viz in SAP Fiori consuming one of the view. Maybe I will show you that if time permits. When we will build our Fiori app at the end, maybe I will think about it with one example and show you this data over there. Yeah, and then you can also use something called an select query, put it in an internal table and then show it in an ALV grid. That is also a good option. So the whole idea now is this information model. As an ABAPer, I'll tell you my perspective as an ABAPer. Somebody from HANA experience would have already developed in your company. As an ABAPer, what you need to do is consume it. Okay, and that's what we will see in upcoming chapters, how to consume an information model built in HANA in ABAP. Okay, absolutely. How will an end user consume this view? That's what we will see. That's what ABAP on HANA is all about. There's an information model in the system in HANA DB, and somebody from ABAP team has to now consume this data from ABAP and expose it via a ALV report, or could be a simple report, or could be a Fiori app, could be a web intro app, whatsoever. Yeah, you got to write a select query on this view. Basically, that's the whole idea about it. We will see that. So right now what we have done, just to also represent pictorially, since there are too many questions about this view now, how the overall picture would look like. So what we have done over here is we have three different layers. If you remember, once again, our three-tier architecture. So we have your database layer, we have your application layer, and then you have your presentation layer. So presentation layer is nothing but about your Fiori app which you're building. In application layer, you will write your OData implementation. And then in database layer, you have actually created an attribute view now. So this is, you have created database level, right? This view you created database level. So how would you consume it over here in a ABAP layer? So there is a concept called proxy, view proxy in ABAP. We will see this concept in upcoming days. So we will create a view proxy to basically pull the data directly from this view in ABAP. That's what we will be seeing. Okay. And then this view proxy would, you can fire a select query on this view proxy. Actually, just the way I'm showing is writing a select query here on this view directly. You can write a select query on this view proxy. It gives just a proxy to talk to this view in ABAP. And then you can write a ABAP OpenSQL to query this view data. And then you can create an OData service inside which you will call this view proxy. Okay, that's what you will do. And that expose this OData service to your Fiori app, which then is consumed by Fiori. And in Fiori now you can display a nice visualization inside your Fiori app. You can actually create a nice visualization using sap.viz library. You can create a nice visualization in SAP Fiori and display this data in form of a chart or in form of a pie or whatever you like. You can do that. That's completely possible using SAP Fiori. Hope you are able to understand, guys, the end-to-end picture about consumption of the views. Hope this is clear to each one of you now. Yeah. So that's how you can now showcase this sales data in the Fiori UI. Is that clear to everybody where we are heading towards? So we are here, we are building things here. Why? To minimize this data transfer between the database layer and the application layer, and to push down as much as calculations as much as we can into the DB layer. Which is, what is this paradigm called? Anybody? This we have, I have already discussed in previous chapter. What is this? Yes, perfect, Shilpa. It's called code to data paradigm, where you are now pushing down all the complex calculations into the database layer. You're performing the joins in the DB, you're performing the calculations into the DB, and just transferring the final result set what you want to see on the UI, rather than doing a select star from first table, select star from second table, select star from third table, pull all the data in application layer and then loop and then process. You're doing all this is directly in the database layer, created a view which finally gives you the final data set. Again, further on with your select query on application layer, you can filter the columns and pull the data and display it in the Fiori app. That's the ultimate goal here, what we are trying to achieve. Code to data paradigm. So that's about your attribute view. Let's see some more features. So now next important aspect is about the joins. What are the different types, variety of joins we have in HANA, and how would these joins make sense for us? So I have some time back explained you about concept of text table. Can anybody tell me what is the concept of text table? Anybody? You can unmute your line and tell me about text table. What is a text table? Anybody? In ABAP just now, some time back, I have explained you the concept of text table. What is a text table in ABAP? Anybody? You can unmute your line and tell me what is a text table. Anyone? What is the definition of a text table? No. Partially correct. But is that what you will say in interview? A text table contain text, right? This is what will you show. So I remember my schooling days when there was a question in my college, so in my school, what is Einstein law of energy? So I am bad in spelling of Einstein. So what, you know what my answer was? It's a law given by Einstein. Yeah. Is this do you think I would get some marks on this answer? That's why you get rejected in interview, guys. That's the exact reason you get rejected. And then you say, "Arey yaar, sare answer sahi diye the. I know everything. Still got rejected. Why? Because this is the answer you gave. What is Einstein law? Law given by Einstein. Is this the law of Einstein? It's E equals to mc square. That's the law of Einstein energy conversion principle, right? So if you don't put E equals to mc square, you're not going to get any marks. Whatever you type, whatever you write whole Ramayan, you will not get any mark. That's the biggest problem, guys, in us. We know concept, but we are unable to frame answers. We are unable to convey the knowledge which we have to interviewer or to our colleagues or to our manager or whomsoever. And that's the biggest thing which you need to learn in life if you truly want to become a big developer, an architect or associate developer, whatsoever, wherever you want to go. You need to start thinking in this direction, how to frame your answers. So what is a text table? A text table in SAP holds the language specific texts about master data. It includes same primary key as main table, along with that an extra column called language column in the table. I think I did not discuss here in this training session. I discussed in my morning class with Fury friends. So there I have explained, I think when I was teaching internationalization, I-18 and concept in Fury, there I showed this concept, not in this batch. So text table in SAP hold that language specific information text about master data. It includes same primary key as the main table, along with that an extra column called language column in the table. Okay, language column name is Espras. Typically, this is the language column name. Now, what is the purpose? Let's take an example. Now, I have in my EPM model my product data in product table. So if I quickly show you here, if I go to SQL console and fire a query on my product table, you would see my product data over here. Just remove this and just fire a query on my product table, execute. You would see my product information in this with this query. So this is all my product data. Now, do you anywhere see the product name? Guys, do you anywhere see the product name in any of the column? Do you anywhere see the product name in this table? Some people may think, Are yera. No, it's a category of the product. It's not the product name. Which category the product belongs. Okay. We don't have it here. We have only the product ID. Okay. So we don't have the product name in this table. Why? Because SAP is famous for language also. You run a SAP software in different language, you get majority of the results already translated into a different language. Why? There's no magic happening. The data which you have in the system also sometimes translated by the translators, so that when you look at the data in different language, it gives you a perspective. It gives you different language information. So the name of the product is stored in a text table. What's the primary key of this table? Let's look at the primary key of this table. So right click, open definition. Let's look at the primary key of this table. So primary key of this table is essentially, I think this node key is the primary key of the table. So if I right click and say open the definition of my product table, you will get to know the primary key of the table. So you see, it's the node key, which is the primary key of the table, along with the client field, mandate field in your SAP. So this is what the primary key. Now one question, let's see who can answer. Basic database question. Can you have more than one primary key in a table? Can you have, who is saying yes? Everyone is saying yes. Okay. Guys, you all will fail in interview except Subani. You all will fail in interview, guys. You cannot have more than one primary key in the table. So bad. Guys, you cannot have one primary key, more than one primary key in a table. It's not possible, guys. Then you will say, Anubhav, in this case, we are seeing it. See, client is there, node key is there. No, guys, assumption is incorrect. What is the definition of a primary key? When you look at the definition, you will understand it. The definition of a primary key is a primary key in a table is a column or collection of column which uniquely identifies a record. That's what a primary key definition is. A column or combination of columns which uniquely identify a record in the table is called primary key. You cannot have more than one primary key, otherwise you're violating the primary key constraint. The purpose of primary key is to uniquely identify a record. Let's take a quick example. I won't spend much time. I was anticipating at least people, you have some knowledge. Let's take an example of an order table where you have order number, date, amount, and let's say quantity, or let's say region. Now my business says daily when I open my shop, okay, my order number must start with 1. Okay, when I open my shop daily, my order number should start with 1. So if you have order number 1, let's say on 1/1/2017 you made a sales of 5,000. Let's take it as a US region. 1/1/2017 you made a sales of 6,500 in US region. Now next day you come and open your shop. What will be your order number starts from? What is your business says? What should be your order number on next day when you open your shop and you make your first sale? What will be your order number? Anybody? That's what your business is saying. It has to be 1. Okay, it has to be 1. Next sale which you made on the same day, it has to be 2. Okay, now can you uniquely identify one record based on order number? If you say yes, then you see here this record is also order number 1 and this record is also order number 1. Which one you will say? How do you uniquely identify the record between these two? How? You cannot. Can you identify your record uniquely based on date? Anybody? Can you identify your record based on date only? Based on date only based on date? No, you cannot. See, second record also have same date. So what shall I do? I need to use 2 columns together now, which is order number and date, because I know every day within a day order number is unique. And every day I open a shop, my order number again repeats. So I will say my order number together with the date. Okay, my order number together with the date is actually something which I would consider as my key, which can uniquely identify a record. Okay, my order number with the date is something I can say together can identify. So if I say on 1/1/2017 order number 2, which means I can exactly trace my record. This is the record. There's another record with order number 2, but date is different. At the same time, if I say a record on 1/1/2017 with order number 2, I can see here this is the same date, these two are same date, but the order number is different. So these two together becomes my primary key. I was so disappointed when you say yes, there are more than one primary key in a table. Never ever say that. The moment you say this with your experience, where whatsoever it is, 1 year, 2 year, 5 year, you're immediately rejected. Interviewer will make its mind to reject you. Whatever questions you answer after that, it doesn't matter. Interviewer, if I am the interviewer, I ask this question. If you say yes, I decided to reject you immediately. I will not pay attention to interview. Just to entertain you, I will ask five more questions. Whether I get answer or don't get answer, I don't care. I will reject you. You cannot have more than one primary key in a database table. It's a column or collection of column which is a primary key, which uniquely identifies a record. Hope it's clear to all of you guys. Basic database knowledge. Now, primary key is made up of two constraints. If you talk about primary key, it's actually called database constraint. It's a rule of database, primary key. Now, primary key constraint is made up of two other constraint. First constraint is called not null constraint, and second is called unique. The definition of a primary key says the column which you have selected to participate to become a primary key has to be not null, which means there has to be some value you must give in the column, and together the value has to be unique. That becomes your collection of column, which is primary key. Otherwise, if it doesn't fit into these two sub constraints, it's not a primary key. Okay, these are all two additional sub constraints which has to be there. If you allow order number to be kept as null, there is a possibility that on a different dates two order comes with null, and then you can't identify which one you're referring with order number, because there are multiple records with order number null. Okay, so it has to be not null, which means you cannot leave that field empty, not null, and it has to be unique if you are considering a primary key. That's the sub constraint which you have to follow to make a column as a primary key. So now coming back, you see this is not null. You can see not null and marked as key. That means these two columns together makes your primary key for the table. That's your primary key, guys. Hope it's clear to everyone. I need affirmation from everyone. Say yes or no. It's clear or not. I'm very disappointed with your answer, guys. All of you. Primary key. Never ever answer that you can have more than one primary key. Very bad. And by the way, it's a tricky interview question. Somebody can nail you down quite easily with this question. It's a collection of column, or it could be a single column, but the idea is to make it unique. Identify the record uniquely. It's not null and it's a unique column. That's your primary key. If you go and check in DB table with client and node key combination, you will see every record uniquely. Clearly, you can say, okay, this is my unique record, which means in a different client, I can have same node key repeated, but still my record remains unique because my client is different, right? Because it's a collection of two columns. Foreign key is also a constraint. Foreign key is a constraint between two different tables. Okay. Foreign key is also a constraint between two different tables. When it comes to joining two tables, foreign key constraint gets applied. And that's what we are realizing using joins. Using joins, you retrieve the data because there is a foreign key relationship which exists between two tables. Okay, let's move on. Now, where we were talking about tax tables. So I will now show you the tax table in SAP system, which will hold the information about product. So you can see here, there are three tax table which I can see. Let me see which one has the product information. So I'll just quickly double click on the table and see which one has the product name information in the system, so that I can show you the structure of the table and relate it to the text table concept. Okay, just look at the data preview, right click, Open content of this table. There's no data in this. Fine, no problem. Let me check the next one. We have some data, and I think here we have the information about product names. So you see, there's this language key which clearly says this all the texts are in English language. I'm not sure we have German text also, but this table contains now the language specific text about the master data, which is product in this case. So if you just right click and then also can look at the definition part of the table, you would find the relation between them, the text table and the main product table. So I can now read the description of the product from the another table, and you see here again this is a primary key, and the parent key is going to connect to your product table. So this is a foreign key relationship. The parent key of this table, text table, has an identity, has a relation with the table in the product table. So let's quickly write a join query and pull the information about product for English language, all the product description in English language. So I want to, now my requirement is to write a select query to get product data with from product table the product ID, and from text table the texts. Was it the text column? Yeah, it's just the text column for English language, let's say. So it's just a text column as PD join, and then my text table drag and drop and put the join condition. You have to get your hands dirty into the code. It's not possible to learn SAP ABAP on HANA until you write every single query in HANA DB. Do not expect me to give you a pill with which you learn and perform in the company. You cannot. You get your hands dirty into the code, guys. Go ahead and write 10 queries. Let 8 queries fail out of those 10. But you have to do it. Otherwise, no, not a possibility to learn. Node key from this table, and then texts table, I have parent key. This is the relation, and I'm selecting 2 columns. Let's look at the result. We should now get the text for the product. No, we are not getting. There's something wrong. Let's go and check. So there's this parent key which should connect to the node key, I think. Node key in the product table. There's a parent key here. Or maybe is it just the node key between these two tables? Let me just try. Is the node key getting connected between the two tables? I don't think so. I don't think so. No, it's the parent key from the text table. Okay, let me check my first table, which is product table. This is my product table. I think there is a dedicated column for that. You can see description GUID in the product table. I think this is what is connecting to the parent key of the text table. Description GUID, DESC GUID. Let me try this and execute. And voila, you see, for product, this is the text. Okay, for product, this is the text. Every product, this is the text. Perfect. Now I want to see only the text for English language. So I can say where my texts table language is equals to English. Execute. It will only give me the text in the English language for my product. You can see from both the tables considering the join. Now if I want in German, I can say D. I don't think so there's a German text available in my text table, so it will give me empty results. You see there is no German text available. So let me just for one product showcase inserting one German text. So let me just right click and say generate an insert statement. I will just generate an insert statement, insert a data in German language for one of the product. So let's try that quickly, just to showcase you that how does this relation, how does it making sense. So now we come here and look at the data in the text table quickly. Just do a data preview. For one of the product, I'm going to maintain this, guys. Yet again, I'm not a big fan of having multiple windows. So just quickly run it for English and see for one of the product, we'll convert it to HT1000. I'll do it. I want to know what are all the different columns. So open the definition. I of course need the GUID to be created. So I would need a GUID which can connect these two tables. So there is this client field which we have also in the table. So I will just now do a select star from both the tables. So I can get the desired things copied from this select query. Okay, so I would need for HT1000, this is the product. I would need the GUID for the description. This is the GUID for the description from the table. So I take this GUID. Okay, I can't. This is bad. Copy to file. I copy this. Let me just put it in a notepad. And I would need this GUID 626BE, which is the GUID 626BE. This is the one. This is the text GUID for my record. I come here and here I have to insert also a GUID for the table. And what's the client field value? Client is 001. So first field in my insert statement is 001. Then my new GUID here, I have to just put some sample GUID for my new record 9999, let's say. Then the next column in my table is, let's see the column. Node key, parent key, I have to just put some parent key again. 5454. And then next column is language. Okay, in the parent key, I have to put the description GUID actually. So I have to put in parent key the description GUID for the product, which is this. And then I just have to put language as D and some text in German language. So I can just put some text for this product in German language. I say Anubhav is here. That's a description for the product in German language, let's say. Okay, let's say in German language. Execute this statement. Incorrect syntax near D. I think it's not accepting D. Let me check. So third is language, which is string type text. No, it has nothing to do with that, I think. So first is client, GUID D, and Anubhav is here, and then this. Let's try. Okay, it's one single character. Okay, got executed, inserted, guys. Let's quickly check now. Same query which was failing earlier. Now I'll just say for D language, what's the data for my product table? And you would see only one product we have now, the German language data. You see the record is coming. So that's how your text table works, guys. And you see text is Anubhav is here. So this is how text table works. So whenever you are joining your database table with text table, it's a special type of join. It's called text join. So in which you have to specify which is your language field from the text table. So system automatically cannot determine which is the language field. You got to specify that. So now come back to our attribute view, and we are gonna just go ahead and define a join with our product description or product name table also. So that's why I'm just creating some space here. I just also add this main category to the output, and let's bring in our table, new table for the description. So SNWD text table. which is product description table. And this time, remember, the join type is going to be a text join. Let's maximize this. These are all the core concepts of SAP text table. This concept is has come from SAP actually. And now we know that the parent key should match with this description GUID. And then this join type is actually a text join. You can choose here, and you can specify the language column, which is the language column from the table in this join. Now I did a mistake, guys. I stretched a arrow from right to left. That's not correct. It should be from left to right, because for this description I'm going to drill down and check the description information in the another table. So it should be left to right. Double click again, text join, and then in the check table you can choose the column which is the language field. So language is the name of the field which will be used to identify the language. Okay, we do this, click on OK. We're done. Let's activate our data model. Oops, I forgot to include the text into the final output so that you can see the results better. So you remember last analysis which we were doing, we were actually we were seeing only the product ID. We were not unable to see product description. But now since you have added the text column and language field also is specified. So current login language to HANA system is English. So it will pull the text from the text table based on English. Okay, it will automatically do that for us. So let's go ahead and do a data preview now for the activated data model. Let's do a data preview. You would see the text also. So now you can actually do the analysis in a better way. So I can say my label access is text, and I want to see how many total or what is the price available. So you can see now the texts are coming below. You can also do a count of company. Actually it more or less comes to the same because same product has been added twice. So category wise you can see, and if I just put category on the top and text on the bottom, we will see some different results. So this is category axis. I put text on this axis, so you see the data. Okay, let's do a raw data preview, and you can see now in the raw data preview you're getting this information about the products. And you see the text of the product is also coming. So the main category, the subcategory of the product. So main category, you can see it's a computer components. That's the main category of the product. Within that you see speakers, notebooks. These are all comes under the subcategory. And then within the category you have the different products available. Yeah. So this is main category, subcategory, and the text. So if you look at this is actually a hierarchy. So how our product data is structured? So you have a main category, then you have a subcategory of the products, and then you have finally the products, multiple, right? You have multiple products in the bottom. So there in the main category you can have multiple subcategories, 1 to n again, and then you have multiple main categories. So an example for that, if I show you here in our real data, let me fire a select query on this attribute view once again, just showcasing the main category, subcategory, and the product descriptions. Okay, let me do that. So I come back to our HANA query, double click here, you get the view name on the left side. Just go back, fire, just select main category, category, and the texts from our view, and execute. You again further minimizing the number of columns. Okay, you're again further minimizing the number of columns from the output. Just execute and you see the data. You can also do a sorting here. No, we can't. Okay, so you see computer systems, it's a notebook. computer system accessories. So this is the main category. Computer system software is another main category. Computer components is again another main category. TV, video, hi-fi is again main category, under which you will see further products. So PC comes under computer systems. So that's a hierarchy of data in the system. Okay, this hierarchy is quite useful for us. Okay, now if you also look at your data preview, which we were seeing earlier in the graphical editor, you can also look at the number of products under main category. So on the label axis earlier I was just putting category, you can now put main category and see the total count. So you can see in computer we have 40 products, 40 plus products in the computer systems. Again, computer components, actually computer systems, we have 30 products. Printers, we have 13 products. Now same thing, if I do it with the subcategory, you see more data. So this is all your informed decision you can take based on this master data actually. Yeah, this is one very simple example, guys, of dimension. What I'm taking, I'm spending a lot of time to explain you how can you analyze dimension data. Now what we will do is we will want to drive this data in more hierarchical order. So I want a hierarchy to be displayed to me in the system with main category, under which subcategories, and under that further on I want information about the product. So we need to create a hierarchy for the attribute view. And when you combine this attribute view later point of time with your fact table and build an analytical view, that time that category becomes very important, because then you can further drill down. So hierarchy always gives you drill down information, and when you further drill down you will get to know the revenue, or let's say sales, done at main category level, subcategory level, and product level. So like which you can analyze the details at different levels, and this is called level based hierarchy. Okay, so there are two types of hierarchy in SAP HANA. One is level hierarchy, and second is called parent child relationship, parent child hierarchy. So hierarchy is used to realize data based on relational relation of data characteristics. So data has characteristics. Based on relation characteristics, you can analyze the data further on, and that becomes a hierarchy in HANA. Okay, so it's a characteristics, external characteristics basis analysis. There are two types of hierarchies in HANA. This is a very important interview question. One is called level based hierarchy, and second is called parent child hierarchy. A level based hierarchy is a hierarchy where you have relation between master data with respect to groups. Okay, basically it's a group related information. Like in this case, you see main category, it's one group, and then you have subgroup, and then under that you have subgroup. And it can also come from multiple tables. These groups can come from multiple tables. Like in this case, if you look at our data model, what you see is main category is coming from a different table. The category itself is coming from product table, and the text, which is the last level, is coming from the text table. So you see three tables are involved in a level based hierarchy. Okay, yeah. Now next is parent child. In parent child, the relation works as self relation. Okay, the hierarchy relationship is based on self relation. Okay, in which the table has a relation with itself and mark one of the column as parent and another as a child. Example, manager employee relation, right? If you remember, I showed you example about employee table. Same employee table has manager data also, same has employee data also. So if you want to display a hierarchy of who is reporting to whom, will you have two tables here? Of course not. You have only one table, wherein manager field or employee ID with a special characteristic is actually the parent. Employee without having that special characteristics is an employee. That's a parent-child relationship, parent-child hierarchy. So right now we'll see an example of level-based hierarchy. Let me create one for this example. So I will just go back, click on semantics, go to hierarchies, click on plus, and I'll say my product category hierarchy I want to create. Product cat. I just write a label for this. Product category hierarchy, level based hierarchy it is, and I'm just going to add all the levels. So I say first level add, and my column which is going to make the first level 1 is main category, then level 2 is there's a subcategory, and finally the final level is my text of the product. These are all the three level of my hierarchy of my data. Click on OK. Hierarchy is created. Let's quickly activate. You cannot see this drill down capability of hierarchy in HANA Studio. You need some tools to consume this information and showcase on the results. Okay, so we will use Excel sheet to display this data. But before we do, we need to now go and create our analytical view which can derive some productive data for our used case. So I'm now going to join my table, my attribute view which I have it here, which is nothing but a dimension with my fact table, and that is typically done. You can actually do it here also. Okay, you can join your sales data table with this setup here itself in attribute view also. But would you do this? You can do it, no restriction, but you would not do it because typically when you want to join with a fact table, the concept says use analytical view. Why? Because there is a concept of aggregation involved. So now actually I will not be able to complete this topic, guys. If I start this topic now, it will take about again 30-40 minutes. So I would like to park here our session, and in next class when we come up, we will start with analytical view. Okay, analytical view. Now at the same time, I'll quickly want to show you another feature here which is called calculated columns. So as you remember, we were saying that code push down, calculation in HANA DB, calculation at DB level, code to data paradigm. You can also calculate the data, apply some formulas and calculate the columns at runtime in HANA, and that's called calculated columns. Suppose I want to display a column, I want to display gross amount, okay, some column or let's say some amount or the product price with 10% discount. So my requirement is display the product price, but also display the product price with a 10% discount. So I can write a calculated column. Right click here, say new, very simple. And now you would get a nice tool for calculating the data, and you say discounted price, and I say 10% discounted price, and you can choose the data type as an output. So output data type is basically a decimal. Okay, and I would like to probably keep this data type same as what my price column data type is. So I will just quickly go back and check that in my product table. So here is my product table. Right click, say open the definition, and let's see the data type for my product table for the gross amount, sorry, the price of the product. Yeah, so now if I just come down, I can see price is decimal 15.2 fixed. Okay, it's a decimal 15.2. So I would create my calculated column on the same fashion. So I say new and I say discounted price, and I just say discounted price by 10%. I say decimal. Anybody remember 15.2? And then here we can apply a formula. So you see, if those who have worked with BRF plus in SAP, I have given BRF plus training in past, some of you might have attended. So it's more like a BRF plus UI where you can quickly calculate formulas, absolute values, a lot of different stuff you can do. There are a lot of string functions, concatenation, conversion functions, mathematical functions, spatial functions for locations. Basically you can also calculate different locations, um, and then some miscellaneous functions available, and then with arithmetic operators. So I will calculate the final price. So I will say my current price for every record should be taken, and this price should be multiplied with the 0.9, and that becomes my discounted price for the product, 90% of the price, which is 10% discount. Click on OK, and it's in discounted price column. Let's activate the model, and you would see now a new calculated column on fly for every single price. Yeah, so let's execute it. Let's look at the log. You see it's running at the bottom, and then we can quickly look at the data result finally completed. And let's look at the data preview once again. You can also just close all the things not required, do data preview, and you would see the calculated column data in raw data. I would love to fire rather than a query on this view to look at the real data. So let's come here, and I just want to say I want to select the price, discounted price, these two columns, execute it, and then let's see the result. Oops, I think my column name is incorrect. It's discounted price. Was it correct? Mm, execute. It's not taking. Let's just put star. Why is it not taking? And just come on the right side. You see discounted price. I think I'm doing some typo, guys. Discounted COUNTED price. And execute. Oops. Invalid column name. Oops, some problem. Let's look at the column again. Double click on the column. Go to semantic. This is the column name. This is all fine. Why it's not accepting it? There's some problem. Let's go and check one more time. I just pasted it from there directly. I copied the column name from there in the calculated column name, and I'm now putting it. I also want to include the product ID, or let's say texts, the name of the product. Execute. It's still not taking, guys, my column. There is some problem. You see, it's saying invalid column name for discounted price, not for the price column actually. Okay, there is some problem. So you see, it's at least showing this. There's some problem with my column. Is it a problem or what? Execute once again. You see, it's showing here, but when I'm trying to query it with the definite column name, it's not allowing me. Discounted price. I think some typo issue. But you can just make out, I guess. Let me just scroll left and show you the price of the products. You see 26 here. Yeah. So you see price is 26. If you scroll to the right, you see 23.4 it has become. Yeah, that's your discounted price. So 10% went off, and it has become 23.4. Now you see it's coming in decimals. I want an absolute value to be calculated. So you can do further enhancement of the column. So you can come back, double click, and I can say calculate an absolute value. So here, come down in the functions. There are a lot of functions. I say just search for ABS. It is the absolute function which calculates the absolute value, and I just put my price into 0.9 inside this to calculate the absolute value of the price, so that no decimal points comes up. Click on OK, re-execute the model, and let's look at the log. If it's running fine, you can see it's running fine. Let me just restart my SQL console. Yes, more like CL function what you have done. Perfect, El Hadi. So this is something which we did here there into ABAP system. You are doing now in the HANA system. So you guys can make out that things which you've done in ABAP system, now you're doing purely in the database. What does it mean? It means calculating the final data set in the database. We will also apply currency conversion right into DB itself, guys. I will show you that in the next class. Okay. So that there also you will save a lot of time. Only final data result set is what you got to transfer back to the ABAP. Yeah. That will be the whole idea about it. Okay. Let me just put the view again. Select star from. Let me give one more shot. Product ID price discounted price from my view, drag and drop and execute. Yeah, go ahead. Oops, again discounted price is causing an issue. I don't know why it's not allowing me to select that column. Okay, I just get this. Let me just do a star one more time for all the columns and show you the value. So earlier we were getting the discounted price with the decimal value. So you see 26 here is the price, and I scroll down and see still, oops, it's not calculating an absolute value. Still it's 23.4. It didn't calculate the absolute value, guys. So I think there's some other function, maybe we call it a mathematical function, to do a round off. Yeah, here we have round down and round function. Let me use that round function, guys. Yeah, do a okay, re-execute, let it activate the model. So you got to explore these functions. And by the way, guys, I'm not an expert on HANA modeling. This is something which is the basic thing I already know about it. I work little bit on HANA modeling, and I thought it's good if I share my knowledge with you guys so that you can, in just in case if you get a chance to work, you at least don't feel so much disconnected about it. Okay, I think the round function is also not working. Let me check which category the round function comes. It's a mathematical function. Why it's not working? Okay, ABS round sign. Let me just do a Google then. What's wrong in that? So I just come here and say calculate or round off decimal HANA calculated column. So this is how you can truly learn things. So you see there's a round function which they are showing. I think it should work. And even it's a conditional rounding, and you can see here round function, there's another argument called 2, which means round it into two things. Okay, let me try. So multiplication comma 0, I want to do a round of 0. You can also do one thing. To want to see the signature of the function, just double click on the function. You see it accepts 2 arguments. That was our mistake. We were only passing one argument, which was multiplication. We have to pass the second argument, which is how much you want to round it. I want to round it to 0. Click on OK. Again, activate the model. Let's see if it works. So waiting, running. I'll see quickly if this works. So you can also do complex concatenation, string operations, calculating absolute values, sine theta, cos theta, all the different type of variety of aggregations you can calculate, evaluate right into the HANA database. Okay, this is completely possible. Okay, oops, I clicked on again activate by mistake. Got to click on data preview, and then let's have a look at the final result. Raw data. And then you see discounted price is, wow, rounded off. You can see 23 it has become. So all the data got rounded off to the lower value, next lower value. Yeah. So that's how you can apply and calculate new functions. Of course, we will use such features. We would love to use such features to do calculation for OIA for Mr. James. You remember the used case? That's going to be our ultimate outcome, which we got to produce at the end of the day. So this is just an introduction of attribute view. In the next class, we will start with analytical view. There are more powerful features like import parameters, restricted columns, calculated columns, variables, and then you have hierarchies in action. I just created an hierarchy, but I didn't show you it in the action. We will see that. We will also understand aggregations, measure calculation using analytical view. How does the processing is working? So all these things we'll see it in the next class. And of course we will talk about yes, we will talk about stored procedures. We will discuss about that in brief, but before that, more important is to understand calculation views and also to look at SQL script, because one of the technique to build calculation view is SQL script. So we will learn SQL script because that's also something which is going to be useful for AMDPs, ABAP managed data procedures. Okay, so that will be useful for us when we learn about SQL procedures. So Shilpa has a question in ABAP DDIC. I could check the list of tables that the current table is connected via foreign key relationship. Is it possible to see same in HANA Studio? So can we check the foreign key relationship then right joins? No, HANA Studio, HANA level, there is no constraint at the database level. So what happens in typically in SAP? When SAP creates the artifacts, we always use data dictionary to work with. So we are here in the application layer, and data dictionary as a concept works in application layer. Okay, so DD concept works in application layer. So all the constraints what you have, major constraints are managed. So let's look at a database. Now database doesn't know what is a structure, what is a table type, right? It doesn't know what is a lock object, what is a match code. All these concepts are SAP DD concepts. What database just know is actually template, DB, database table, views, column views. Yeah. So there is an abstraction which your application layer does for the database layer. And what happens when you also apply this foreign key constraint? It is managed at the DD level only in the application layer. It is not transmitted to the database layer. In some cases it is, in some cases it won't. So the current SNWD model what we have, the database constraints what you have, the foreign key relationships are not transported to the database layer. So it's only managed at the application layer. So you can only see it in SC11. So if I just log into our server, and I'm not sure whether you'll be able to even see this here, because if there is indeed truly a relationship between our tables or not, I want to just quickly check. I don't think so. We even have a relationship now here, and that's actually a good flexible design that you physically don't enforce the constraint, because then you have a flexibility to change things in future. Yeah, that's a good DB design. If you physically, especially foreign key, primary key you have to put it, but foreign key you should not. So I come to SC11, click on the button where you can now see the relation between foreign key relation between the tables. So you can see here it is available, but this is something which you cannot see in the database level. Okay, you cannot see that at the database level. But of course, maybe my knowledge is limited about the Studio. I don't work much with Studio, so maybe I will check that and see if we can find it. But my understanding by far is the relationship is enforced at DD level, not at the database level. The constraint, foreign key constraint, is not transported to the database. Okay, you can also see the DB object here. Quickly just see. You can see there is no foreign key constraint. It is showing in the DB layer when you look at the DB object of the same. But still, I'll cross check that, and if I can find some related answers, I will get back to you. But right now, you can use application layer, you have this graphical option to look at the relationship between tables. Okay, great. So with that, it's a wrap on today's class. See you tomorrow. See you next weekend. Have a nice day and goodbye.